Well, hello everybody. Welcome into Great Atmosphere here on January 11th of 2024. Just going to take a look real quick at our global satellite view here in true color. Got to see a quite a significant anticyclone high pressure system sitting off of the Azores right now in the mid-Atlantic. It's always quite interesting to look at some of these features because, especially from a satellite view, because they are obviously exceptionally pretty, but you can also tell quite a bit about what to expect with the synoptic pattern of weather based off of it. So here you can see the El Nino based or Nino 3.4 based subtropical jet making its way across Mexico, the Gulf, and into the southeast. You see obviously our big high pressure system influencing a lot of low pressure movement. You see our polar jet stream starting its dip down into the contiguous U.S. You see our baroclinic leaf. You see exceptionally cold temperatures and cloud decks here in the Canadian prairie. You can see quite a lot just by looking at satellite, and it's just exceptionally pretty to look at. So I just wanted to start out with that. Some sad news, actually, to start this off. We did mention earlier yesterday that the National Weather Service in Greenville-Spartanburg would likely be looking at an area in the Catawba region northwest of Charlotte. And unfortunately, there was a confirmed fatality and 4 injuries associated with a EF1 tornado that had made its way in the Catawba region. I think the general track was right here, just beginning south of Newton and actually crossing I-40 before dissipating. A couple of problems with this specific tornado. It was not tornado warned by GSP, which I don't particularly... naturally, people online will say, oh, this is a major fault on the National Weather Service office's part. I actually don't attribute this at all to that. I attribute it more to poor legislation in the area. We can take a look at some of the details that the report gave. You can see essentially the house that the person who deceased was living in was not made to code, as a lot of houses actually are not in the southeast because, unfortunately, the builders like to cut corners, and they don't think that tornadoes or any major severe weather is ever going to negatively impact the structure that they're building, and they'll dig shallow holes, as was the case with this particular manufactured home. Essentially, the entire home came off of its foundation and rolled, which ended up killing the person that was inside, and then the additional injuries came actually from the tornado crossing the highway. So that's a problem, obviously, with legislation in terms of permitting and getting that done. But the other major thing is I watched this system as it came through pretty much minute by minute, and I didn't see anything that would denote a tornado. I looked back on the records. I didn't see anything that would, generally speaking, scream tornado. And that definitely is the fault of there being a significant radar hole in the Charlotte region. So I'm going to bring over our radar map that we have available. So in the Charlotte actually is the largest metro region in the United States with almost 900,000 people in its metropolitan complex. That is not covered by a WSR 88D radar within its town limits, or within 30 miles of town limits. And what the WSR 88D is essentially it's like a modern radar. So like able to see at great distances and can see a variety of different parameters that can actually be able to detect multiple different kinds of weather. The radar that is present, and you'll see there is a dot here in Charlotte, that particular radar is I believe it's a TW, what is it? What's the acronym? I have it right here. It is a TDWR, sorry. Essentially, these were installed starting back in the late 80s, and they were primarily made for airports that were experiencing high wind shear and wind gusts when planes were landing. And this radar specifically, although it can see different, it can see rain and whatnot, the resolution is obviously quite different, and it's made to only detect shifts in wind patterns on a base velocity scale. And it doesn't even go up to the base velocity that you see, it's not able to detect high speed winds that you would see in a tornado. And in this particular circumstance, it was not even, it does cover that general region, but there would be no shot in that particular radar sensing it. So where are the WSR-88Ds, the good ones? Well, the closest one is all the way in Greenville-Spartanburg. That is way too far. So generally how radars work, I will draw a little bit of a picture. So we have our radar here like this, and the radar is just constantly shooting out different radar beams. Okay, so that's a beam, and it will shoot these in various different tilts, but it always goes up. And the farthest away that it is, this is the ground level here, the less accurate it is, because the beam is all the way up here. It can't detect things that are all the way down on the ground. So in this particular scenario, the tornado was altitudinally right about here, and the radar was sensing stuff that was going on way, way above it. So they had no chance of being able to see this tornado. And it's quite unfortunate, because now we've had actually, it's not the first fatality by any means that we've seen in this particular region. And you look at, okay, what are the other radars in the area? Well, we got one up in Blacksburg. We have one over in eastern Wake County. And then we have one in Morristown in Tennessee. There's really, and they're completely blocked by mountains. It's not a good deal, and it's quite startling that politicians would be okay with just leaving a general megalopolis of about 1.5 million people to just complete chance. All it takes is one big tornado, and we could have a serious mass casualty event just kind of waiting to happen. And it's a shame that it hasn't been fixed up to this point. So just wanted to get that soapbox out of the way. Thoughts out to the family of the people that are affected. Taking a look now at our water vapor coming into our big weekend. Not necessarily a big weekend here in the southeast, but and definitely not as severe of a storm possibility that we had on Tuesday. Tuesday's main factors were rain and wind, with a couple of spot tornadoes over the course of the southeast and primarily the Florida Panhandle. So we can see here in the mid-level water vapor, the subtropical jet going across the deep southeast and the Florida. And then we have what's called a baroclinic leaf forming out of the Rockies. This is generally speaking kind of the predecessor of a low pressure system forming in the lee of the Rockies, and it will soon form a panhandle low here in the Texas and Oklahoma panhandles, as we've been modeling for the past couple of days. Taking a look first at our upper air heights to see where this instability is first going to rear its head. So we're seeing up in the atmosphere here, we're going to move through time. And then we first get this upper low, or upper trough, I'll say, forming around 9Z, so early in the day, Friday morning, before quickly shifting to the negative tilt here. And we can see, sorry, didn't mean to pull up a sounding. We can see negative tilt if the main axis is pointing in that direction. You can say that it's pointing down. That would be negative tilt. And when we see an upper trough that's pointing negatively, we know that the system is more than likely about to not necessarily bomb out, but deepen quite considerably. And when low pressure systems deepen, you see wind values skyrocket. So you can see our upper level winds start to increase dramatically. And then when those increase dramatically, we look for areas of diffluence out ahead of the system. So we see areas of diffluence right around here. You see these isobars are spreading out in multiple different directions. So that means if there's a lot of wind that's being displaced and moving very quickly up in the upper atmosphere and diverging, that means that leaves a void in the upper atmosphere. And thus the atmosphere hates voids. So where does it have to get its air from? It has to get it from the lower levels. And in order to draw it from the lower levels, it has to bring it up. That is the definition of convection. And that is how we start to get storm systems. And you can see those storm systems start to be represented by these little tiny short waves, these little ripples that you see in the upper level pattern. That's typically an indicator that we have some storms on the way. And this is 15Z Friday. So this starts Friday morning, and then it goes further in as it goes forward. We'll take a look at what this looks like at the surface in terms of surface pressure. That what we just looked at was upper air. So now we're going to look more towards the surface, and here is our low starting to form. It is going to fully deepen here and probably set another low pressure record that because as we mentioned yesterday, Indianapolis did set a lowest pressure record. I believe it was 972 millibars yesterday. It kind of shows the strength of that storm. And you can see, as depicted in the colors, this is above ground layer, 10 meters above ground layer wind in knots. So anywhere that you see this is about 20, 30 knots. That's quite considerable wind there. That's going to be at the surface. So very, very windy. Wind is certainly an issue for this particular system. And not only, mainly, I'd say the main Mississippi River Valley into the Ohio River Valley is going to be the issue, along with the Midwest on the back end, before this turns into a big Great Lakes, probably lake effect storm system for Ontario, the UP, northern Michigan, Wisconsin, and as we move forward, the upstate of New York, as it moves off into the future, I suppose, or into the Atlantic. So snowfall for the Midwest is going to be a big one with this, and anytime that you have high winds and snow in the same breath, you get blizzards. So there's sure to be, Chicago is on the way to get its first blizzard in quite some time. We'll take a look at the Kuchera ratio snowfall total that it's predicting throughout the course of the weekend. It's looking at about 8, 9, 7 inches in the Midwest, even more so up in the Great Lakes regions. And this is all going to be blowing snow, so it's not going to be a great time to be in this particular region. Unfortunately, nothing going on here in the southeast. We'll see mainly, and this is all generally lake effect or isentropic upslope flow in the Alleghenies right there. And then we'll move on to our what we're expecting here in the southeast precipitation-wise. This might take a second to load, so give me some time here. So we have that low forming in the panhandle of Texas and Oklahoma. It'll start to deepen and form in the Texarkana, Arklatex region before it starts to get that negative tilt in the upper levels. It will start to deepen quite considerably, and you can see, based off of the moisture transport that we're expecting this to draw from the Gulf, that rain is going to be a factor. Not as much of a factor as it was, mind you, in the earlier parts of this week with our previous system, but certainly enough to create enough moisture initially for the snow to begin, and for us here in the south to get another day of moisture for sure, before it quickly moves out. So you see this is 6Z Saturday. This is about midnight here on the East Coast. So generally speaking, from what the Icon model there in our friends in Germany are telling us, they're expecting this to primarily just be a 12-hour event, probably starting midday in the southeast here, at least starting midday on Friday and ending in the early overnight hours going forward. We're going to take a look at some of the instability that we have in the region, because severe weather was in the cards early on in the week for the system. People thought, it was going to be of the same level of severity as we saw earlier, with the same amount of tornado chances and the same winds. Winds perhaps not necessarily the case for tornadoes. That chance has actually diminished quite considerably in the past 24 hours with new model guidance, and the rainfall rates are going to be lower as well, but we actually already knew that from our previous conversations earlier in the week. So we see those little perturbations, and essentially what we're looking at here is relative vorticity, which is essentially like, where is the energy, where is the strength of the storm coming from? And you're looking for colors of both deep purples and deep blacks. If you have either one of those very close together, you can make a safe bet that there's enough energy in the atmosphere to generate a strong thunderstorm if other conditions are in place. And you can see the majority of that vorticity is shown in the Midwest and Ohio River Valley. And on the back end, this is 21Z, so this is during the heating of the day, Friday mid to late afternoon here in the southeast, as when we can expect a little bit of perturbations here, but they were not nearly as severe as they were looking yesterday. You can see, while we do have some dark blacks and purples and whatnot, we don't see a lot of these big perturbations and short waves that would be our triggers for supercell thunderstorms. One of the things that we always need to look at is the moisture return before these storms come through. We can see in this particular scenario that this is looking at the NAM. NAM is always very good with its precip returns or its moisture returns. This is looking at the 850 millibar low level jet. So this is the primary level of the atmosphere that the atmosphere likes to transport moisture from areas that have high moisture, like the Gulf of Mexico, specifically for here in the southeast, and move it up and into the interior of the contiguous U.S. to begin to spawn thunderstorms. Because what are thunderstorms like? They like differences in wind speed, they like differences in temperature between air mass, and they like they like differences between moisture and dry content within the atmosphere. If you have big disparities between all three of those things, you generally speaking have a very conducive atmosphere for thunderstorms. So we're going to see what kind of, now in this particular scenario, you can see that the cold front is probably situated about right here, with the initial warm front probably way up north. So this is what's called the warm sector. The longer that you sit in the warm sector of a typical low pressure system like this is the more opportunity that you have to generate higher convection totals and thus a higher chance of thunderstorms, which is why I would generally expect a higher chance of thunderstorms in the deep south and the Mississippi River Valley regions for this particular system, because they sit in this muck here for a lot longer than we do, as you'll see. So you see here, this is already early in the day Friday. We're still very dry here in the general southeast and the Carolinas and North Georgia. So you move forward in time, and this is all the way up until, look at this. We're still dry at 15Z, which is 10 in the morning on Friday morning. So we're still dry pretty much all the way up until this gets to us. Instability, I would not expect to be a major concern. It's certainly still there because it is pretty deep moisture as it finally comes through. But as far as actual general risk, I wouldn't place any bets. It would be a very minimum to moderate at best risk. We could take some point soundings here just to get an idea. We'll take a look at central South Carolina and the Columbia to Florence, Darlington region. We're looking at, so it automatically, we can see the hodograph here shows it's actually a very conducive wind shear pattern for tornadic activity, but other things that we're already seeing here are not. We see no mixed layer CAPE. CAPE is our thunderstorm fuel, which is our general speaking convection, so there's not a lot of upward lift. As far as surface to 1 kilometer shear, our storm relative helicity, that is too high of a value to be concerned with. Very low effective wind shear. No 3 CAPE at all. It's generally speaking not too much of a risk in any sense. In this particular sounding, we can look at other soundings just to see. Maybe we back up in time just to see maybe something a little bit more further to the west. We can do some southwest Atlanta sleuthing near the airport, perhaps. Let's see what we got here. So they're definitely detecting more of a severe threat here, and we can see why we have elevated convection here with more unstable CAPE, and we have a little bit more effective inflow shear throughout the column, and we have quite significant decape. That's interesting. And then we have obviously our precipitable water is high, so we expect definitely quite a bit of rain in that particular region. You can see obviously the supercell parameters and whatnot are elevated, so that's always something to keep an eye on. And the hodograph is obviously favorable for some convection moving up into the atmosphere. So definitely something to keep an eye on the further west you go in the southeast, but generally speaking, not a primary concern, and that's actually been reflected by the Severe Weather Prediction Center. So yesterday we looked at this, and we anticipated that the SPC was going to expand. Initially, what they looked at yesterday, it was pretty much like this as far as their main concern area, and that's for both severe wind and tornadoes. You can see that they've shifted more of their focus to the west and added a hatched area. Essentially, what this map, by the way, shows is a 15 to 29% chance of severe wind. So that would be a severe wind gust greater than 56 miles an hour, I want to say, which would categorize a severe thunderstorm warning should the National Weather Service detect it in real time. And then the red denotes a higher probability, and then also the hatched area gives a greater than 10% chance that those same wind gusts were going to go higher than 74 miles per hour, which would be Category 1 hurricane strength in some. But those are gusts, not sustained, so not a hurricane in terms of that. Just a periodic gust, which can definitely take down a tree or a power line. Taking a look at what the tornadoes, so this was all yellow yesterday. There was no hatch because they don't do hatches 3 days out. This is day 2 for them now. So they have reduced the overall risk and then moved some of the risk more into the central Mississippi region. But for the most part, there is diminishing capability for this system. Taking a look at what is going to be expected precip-wise in this particular region, we are not actually, these values have gone down as expected because we saw just how dry this atmosphere is going to be leading up to the frontal boundary getting here. Only about 1/4 of an inch expected in the majority of the Virginia and North Carolina Piedmont, even less so as you get further south into southern Georgia and eastern South Carolina. And upslope flow will obviously dictate a little bit more precip in the mountainous areas, but the main region that we're going to be looking at in terms of severe weather is going to be in this Mississippi River Valley, Memphis, Jefferson City, Paducah, Kentucky, southern Illinois. That's going to be our main problem area in terms of severe weather and blizzards. It's very, very possible that if you follow up the interstate that goes along Illinois here, that you can start your day dodging tornadoes and end your day in Chicago fighting a blizzard. So that's quite significant and quite fun to think about, at least from my perspective. Probably not for the people that are on the highway, but that's neither here nor there. But the other big story coming up after this system is going to be the frigid temperatures that were going to be in place. So this is our 850 millibar temperature anomaly to kind of show what these temperatures are going to look like. And as you might know, low pressure advects wind in a counterclockwise fashion. So you see winds are going to be going in this general direction. And conversely, they are going to be going in this general direction. And they're going to pull the air that is currently in these starting areas up to wherever their position of advection is going to be. So since that low is going to be centered, centered over the Midwest, Indiana, Michigan region, we can expect, and it's going to deepen, which means the winds are going to strengthen, which means the overall pull and advection is going to be quite stronger. This polar Arctic air mass, actually, that's been sitting over the Canadian prairie is going to shift its way down into the north central plains and the Rocky Mountain Plateau in Montana. And we're going to get some pretty significant cold temperatures over the course of the next few days. Taking a look at what that's going to look like, this is on Saturday. This is on Saturday. These are apparent temperature values, so this takes into account wind chill. You can see these are ridiculous. This is Saturday night, 7 p.m., which coincidentally is the same time that the Kansas City Chiefs are playing the Buffalo Bills in Kansas City. So you can expect the game time, this is at 7 p.m., and I think kickoff's at 8. You can expect that they're going to be playing in negative 30-degree weather with a significant wind probability as well. So there's going to be some unhappy people that are both on the field and in the stands for that particular one. But look at some of these values up here. I mean, we got in the Black Hills of South Dakota, we got negative 40. That's negative 45 up in Bozeman, Montana. This is it's probably it's going to set some low records for sure coming out of this. So it'll be interesting to see what that looks like. And it'll persist for the most part. We can actually go back in time to see the timing of this. We'll see it moves very slowly at first, but then gets its act together as we move forward. Friday is a bigger sample size for this particular NBM model. You can see it slowly starting to make its way down south. Now, this air mass modifies over time, so as it encounters the warm air mass that you see influenced by the Gulf of Mexico and the Gulf Stream here in the southeast, it's not going to just, this negative 30 is never going to get here, because in order to get here, it has to fight, degrees that are legitimately 80 degrees total different than it. So this is a big transition period, and the fact that it even reaches down this far is quite considerable. What was that I saw? This is all the way to Tuesday early morning. I mean, look at this. This is the main concern I have going into next week, actually, and we'll definitely be talking about this in terms of a winter threat that might be coming our way in the southeast next week in terms of ice. Some of those analogs have actually come back. We thought that they were gone, but they have actually returned. Ice might still be in the cards early into next week, and this is mainly a big reason why. We have cold air. And since we have cold air, any moisture return based off of this, and if we have any kind of vorticity, remember those energy ribbons that I was showing you, if those coincide with moisture at the same time that cold air, like it's 30 degrees, 26 degrees. This is still apparent temperature, so it's not necessarily the most accurate in the world. But it's still quite significant in terms of getting any kind of icing, and especially if a high pressure system decides to sit off of the coast right here and start advecting cold northerly air down into the mountains, particularly not just down here in the southeast, but this is mainly a cold air damming event that could take place here in the northern parts of Virginia and Maryland and in Philadelphia. We could have ourselves another big mess on our hands. So we definitely want to keep an eye on that, and I'll be taking a look at that in a video tomorrow as well. And yeah, that's effectively it. We have quite a lot going on here today. We got our blizzard starting to peter out here in the Pacific Northwest. We have a blizzard on the way in the Midwest. Still very, very cold out in the Southwest. Our beginnings of a big severe event in the Mississippi River Valley and Texarkana, and another wet and windy day ahead for the Southeast. This has been Great Atmosphere. I appreciate you all tuning in for today. Please be sure to subscribe and recommend this channel to anybody else who might live in the Southeast to be interested in some more in-depth weather discussions. My name is Zach, and I will see you all tomorrow for another Great Atmosphere discussion. Have a good night. Bye-bye.